Okay, so this is your part one of your project for the mini project that you're working on in class Wednesday through Friday this week. It is due by the end of Friday. This is the one over periodic table families. So what you're going to be doing is you're going to create a color coded periodic table by family groups. So instructions are here, but ultimately what you're doing is you're researching the groups of the periodic table, which I have included a PowerPoint on Schoology to help you with this. You'll need map pencils because you'll be coloring. And then you're going to cut out the groups and you're going to piece them together along with a key. You've got some questions you're going to have to answer. And then this is basically how I am scoring it. I will not make you do an oral presentation of it. So, what this one looks like whenever you open it up, here's a key. So, these are all of the families you need to research or you need to know about. You need to know where they're located, what they look like. And then here are your periodic table puzzle pieces. So each one of these is a group from this page right here is a separate, what's it called, is a separate color, okay? And you are going to be piecing these together. So after you get them colored, you're going to cut them out and then you're going to glue them. I have glue sticks onto a separate sheet of paper as looking like a periodic table. So you're going to put the puzzle together. And then you have some questions that you're going to answer. So that's the first part of your project. The second part of your project is over periodic table trends. So this one on your trends, you're going to create a representation of periodicity, which just means that it's something that repeats itself to determine the trends of atomic, we're not going to do ionic radii, ionization energy, and electronegativity values. So you're going to work individually on these tasks and you're going to understand and recognize the trends associated with atomic radii, ionization energy, and electronegativity. Once again, I have a PowerPoint on Schoology to help you with this. So you'll need map pencils and highlighters, and of course the periodic table with arrows, which is in this packet. So this is all of your instructions right here. So please read through them. I'm not going to read them to you because I believe you can read. Um, but here are the questions you're going to end up needing to answer. Um, don't answer number three because number three is about ionic radii, and we're not dealing with ionic radii. This is how I'm grading you. Once again, not going to do the oral presentation. Oops, I'm sorry. So don't do number three. We are not going to do the oral presentation. You do need to make sure you fill out this. So basically, across the period, does it increase or decrease? Down a group, increase or decrease. So you're putting increase or decrease in each one of these boxes depending on what you find out. So this first one here is going over atomic radii. So you're looking at just atomic radii. This is what you do after you're finished with this page right here. So here's your atomic radii, and what it's first telling you to do is you need to go through and create groups of these. And so to create the groups, you just draw a box around each group, just like I did here for you. Okay. Once you create those groups, and then you're also looking at periods, because one thing you're going to find out is periods are rows, groups are columns. So once you have that part done, then looking at what happens on this table here, you're going to put an increase. So you're going to draw arrows to show an increase in atomic radii. So does atomic radii increase this way or does it increase that way? Does it increase down a group or does it increase up a group? Okay, so you're drawing one arrow, one horizontal and one vertical, whichever direction it is for increase. So that's the big key. So you want to show an increase in the radii. So that's atomic radii. The next one you're looking at is electronegativities. So on electronegativities, you've got a periodic table here. It's got electronegativity values, and then it's got a key down here. So what color you should be coloring everything. So it already gives you colors. If for whatever reason you don't have one of these colors, just scratch it out and put the color you are using, okay, or color that box with the color you are using so that I know your key. Okay, so if you're missing a color, let's say you don't have purple, but you have a pink, okay, then use a pink. I'm not a stickler for that. Just make sure that you put the color here that you're coloring up here. So you're going to color this periodic table according to this trends key. So every value has a different color it should be colored. And then once again, you're going to use a horizontal arrow and a vertical arrow on the periodic table to show the trend across the group or across the period and down a group. So periods once again go this way, groups go this way. So when you draw this arrow, whichever way you drew it, so if you draw the arrow going this way, make sure you put whether this arrow means increase or decrease. Same thing with this. You could draw the arrow up like this if you want to. Is it increasing if you go up, or is it decreasing if you go up? So just make sure that whichever way you draw those arrows, you have the appropriate words, whether it's increase or decrease. So you're going to put that on here as well. And then this next one, so I'm going to show it side by side because you kind of have to use them side by side. But what you are doing on this one is ionization energy. So you got a periodic table here. Of course, we went over this the other day. Atomic numbers at the top. You've got a key here. First ionization energy, which is the only thing you're dealing with, is the value that's at the bottom. Okay. So what you're doing is you're going to graph each element's atomic number versus ionization energy up to atomic number 90. So that means all the way from hydrogen all the way up here to thorium. Okay, so thorium's down here. This is number 90. So you go all the way across here, second period, third period, fourth period, the fifth period, and then sixth period right here. Then it goes down to number 58 to 71. Go back up. There's 72 through 86, 87, 88, 89, and then down to 90. And that's where you stop. So this is your graph. So it's got your atomic number down here, and it's got your ionization energy right here. So let's say, for instance, we're going to graph neon. Neon atomic number is 10. Its ionization energy is 2081. So I'm going to go over here. My atomic number is 10. Ionization energy is 2081. Here's 2000. So that's 2200. This is about 2100. I'm a little bit below here, so I'm going to just put a dot. Okay, so that's what you're doing for each atomic number up to there. So yes, you're going to have a lot of little dots, and then you kind of want to just connect them just a little bit. You don't want to connect them like you don't want to do because eventually what you're going to see is you're going to kind of see this little thing going on. You don't want to connect the peaks. Just connect the single runs. Okay, if that makes sense. So in other words, like whenever you get up here, it's going to drop down again, and then you get up here, it's going to drop down again. So just connect this one, just connect that one, just connect that one. All right, don't worry about connecting the peaks. And then once again, on this periodic table here, once you get done kind of looking at what happens, you're going to draw arrows once again, one for the going across a period, one for going up or down a group. Is that increasing or decreasing? Then this last page here is a summary. So summary of periodic trends. Label the arrows with each concept and how it trends across a period and down a group. So in this particular case, the arrows are already drawn for you. So for atomic radii, if you go this way, is it increase or decrease? So you need to put, atomic radii increases. What about ionization energy? Ionization energy increases. I'm so sorry. Or electronegativity decreases, or whatever it happens to be. But you are looking, the arrows are already drawn for you. You just put what the trend is and if it's increasing or decreasing. Same thing with going down. So this is the second part. All of this just stays stapled together. You don't have to unstaple this. There's no cutting. There's no pasting. All right. So that's what your project is. Like I said, you have Wednesday, Thursday, and Friday in class to do it. It's due by the end of Friday's class. I will not be here, so you'll be turning it into the sub. It is still due. And that's it.